Okay, number 14, the coordinates of the vertices of parallelogram ABCD are blah, blah, blah. The slopes of which line segments could be calculated to show that ABCD is a rectangle? To prove it's a rectangle and not just a parallelogram, we have to prove that all four corners are 90 degrees if we're talking about slopes. So we have to find sides that are next to each other, adjacent sides, and make sure that they're perpendicular, that they have opposite or negative reciprocal slopes, right? So we have to compare adjacent sides. So adjacent sides would be like AB and CD, right? If we had our rectangle A, B, C, D, adjacent sides would be AB. AB and CD would be across from each other. So that would not work. We don't want opposite sides. Opposite sides are parallel, and that could be true in a parallelogram. We need to prove that adjacent sides are perpendicular. So AB and BC, those are adjacent sides. If we can prove that these two sides are perpendicular, that they cross at 90 degrees, then we know this is a rectangle. Remember, a property of parallelograms is that if one corner is 90 degrees, then all four corners are also 90 degrees. AD and BC are opposite. AC and BD are diagonals. So F is the correct answer here, A, B, and BC. Number 15, triangle ABC has vertices at A, B, and C. The triangle may be classified as what? Well, let's graph it first to see if we can tell. So if we kind of draw our little coordinate plane, and 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. A is at 0, 0. B is up 3 over 2. And C is over 0, up 1, 2, 3, 4. Then this goes down, this goes straight down, and this goes over. Well, we know that it's not a right triangle. That one's out. Because this angle, this line would have had to be horizontal since this side is vertical for this to be 90, and this is not. It goes down a little bit. Same thing here. This is not a 90-degree angle here. It's much, much less. So there's no 90-degree angles. We have equilateral, isosceles, or scalene. Well, we can quite clearly see it's not equilateral, so that one's out. That means all the sides are congruent. Isosceles means that two of the sides are congruent, right? So the length of this side would need to be the same as the length of this side. Well, we can figure that out pretty easily. We can use the distance formula, right? So this is A, B, and C. We can find the length of AB and the length of AC. So AB, distance of AB, is x minus x, 0 minus 3, squared plus y minus y, 0 minus 2, squared. Negative 3 squared is 9, 2 squared is 4, 9 plus 4 under the radical equals square root of 13. If AC is the same, then we know it's isosceles. If it's not the same, we know it has to be scalene because we already ruled out equilateral, and those are the only three types they could be. So AC, x minus x squared, 0 minus 0 squared, plus y minus y squared, 0 minus 4 squared. This is 0 plus negative 4 squared is 16, so we get the square root of 16, and the square root of 16 is not the same as the square root of 13. This is actually equal to 4, square root of 16. They're not the same, so therefore these two lines, these two legs are not the same, so this is not isosceles. So that means it has to be scalene. Scalene is when all three sides of the triangle are different lengths. Isosceles is when two of the sides are the same length, and equilateral is when all three are the same length. Okay, number 16. 3 vertices of a rectangle have coordinates, blah, blah, blah. Find the coordinates of point C, the fourth vertex, right? So here, D is at 0, 0. A is at over A, up 0. So it's going to be over some amount, but not up anything. So this makes a horizontal line, over A, up 0. Point B is over 0, up B. So we start here at the origin at point D. We don't go side to side anywhere, but then we go up a certain amount, right? And that gives us point B, over 0, up B. Okay, so we're trying to figure out where this point is exactly, right? Point C. So we know this is a rectangle, and we know that one side is horizontal and one side is vertical. So this top has to be horizontal, and this side has to be vertical, right? So how far over, what's the length of this bottom side of the rectangle? Because the top's got to be the same. Well, to get from the origin to point A, I had to go over A units. This is A units long. So to get to this point, I have to go over A units, right? This point's going to be at A, comma, and then how far up do I have to go? Well, how far up did I go here? I went up B units, right? Whatever B represents, that's how far up I went. So I've got to go up B units here. So I'm going to go over A, the same amount as point A, and up B, the same amount as point B. So point C is at the point A, comma, B. It's kind of like more of a theory problem since there's not numbers involved. It's just the idea that in a rectangle, the bottom is the same length as the top. So if this is A units long, this has to be A units long. And the sides are parallel and congruent. So if this is B units, this has to be B units. So to get to this point, we had to go over A, up B. Okay, number 17, find the midpoint of the line segment AB if the coordinates of A and B are A, comma 0 and 0, comma B. Remember, to find midpoint, we add the two x's together, divide by 2, and then add the two y's together and divide by 2. So midpoint, we're going to call it M. And it's a point, so it's x, comma, y. To find our x value, I add my x endpoints together and divide by 2. So they are a and 0, a plus 0. And to find my midpoint of my y values, I add my y values together and divide by 0. 0 plus b. And divide by 2, sorry. So a plus 0 divided by 2. And 0 plus b divided by 2. This represents my midpoint. I can't simplify it right now because I don't know what this little a or what this little b are, but this is how I would find it. So remember, midpoint is a point. The answer is always x, comma, y. It's not a one number answer, it's a point. So it's an x, comma, y. To figure it out, average your two x endpoints together, average your two y endpoints together, meaning add them together, divide by 2, add them together, divide by 2. All right, number 18, last one on this fourth page. Find the area and perimeter of the following figures and give correct units. All right, so the area of a triangle is 1/2 base times height, right? If we were to continue on this side and this side, we'd actually have two triangles here, right? But we only have half of that. So we're going to find the area of this whole big rectangle and then take half of it. So 1/2, 3 times 4, right? So we're going to multiply, which is the same thing as saying 1 times 3 times 4 on top and 2 on the bottom. Same thing. Because these are like saying over 1 over 1. Multiply the top, multiply the bottom. 1 times 3 is 3. 3 times 4 is 12. And 12 divided by 2 equals 6 units. And they're square units because it's the area, right? The area of this triangle here is 6 square units. 6 units squared, don't forget. All right, for this guy, we're finding the area of this rectangle. So it's 3 times 4, 3 feet. Oh, I forgot to do it in centimeters, sorry. 6 centimeters squared. I wasn't paying attention. Okay, this one's in feet. So we're gonna do 3 feet times 4 feet. And this is a flat 3 feet, this is a flat 4 feet, but when we multiply them together, we get little square feet, right? So 3 times 4 is 12. And that's not flat feet, it's square feet, 12 feet squared. Whenever you find area, that's two-dimensional, so it's squared. Okay, and then lastly here, this is a triangle, so we're gonna do the same thing here that we did here, 1/2 base times height. If I wanted to have done this a little easier, I could have actually created boxes, right? And done it this way. Okay, so here's a rectangle. This is 2 units this way. This is 1, 2, 3, 4 units that way. 2 times 4 equals 8. So just this shaded part would have been 4 square units. 4 squared. It's not 4 squared, but it's 4 square units, right? And then for this shaded part, I could have created this big rectangle, and it's 1, 2, 3, 4, 5, 6 units across, and 1, 2, 3, 4 units up. 6 times 4 equals 24, and it's half of that, so it's 12 units. Did I half the other one? Yeah, 4. 12 units squared, this part. And so if I add those together, 4 square units plus 12 square units, I get 16 square units. Which actually makes a little more sense. Mine looks a little cumbersome. Yeah, I don't know why. I would have started off with this way. I'm probably going to cut the other way out of the video so as not to confuse you. I tried to use distance formula and it was stupid. So yeah, I created these rectangles, and then I know half the area of a rectangle is the triangle here. So if I find the area of this rectangle, half of it's the area of this triangle. Find the area of this rectangle, half of it's the area of this triangle, and then just add the two areas together, and I got 16 units squared. And don't forget to say it's units squared. It's not 16 squared. It's 16 square units.